Greetings and welcome to the introduction to astronomy. In this lesson, we are going to talk about what we mean by denying science. And we hear that term quite often. And I want to look a little bit about that and try to discuss it a bit here for you. And once again, this is an enrichment lecture, so it is not directly covered in the textbook, but may be used in a discussion or for other sources within the class. So let's go ahead and get started here. And what we want to say is simply as a starting point, we want to look at science. What is science and what is challenging science? And science should be constantly challenged. We should always be challenging and debating the status quo in science. That is important because that is how science builds and how we improve our theories. This is what we talked about with the scientific method. So if there is an idea, say general relativity, we want to constantly challenge it and push it to its limits to find out the best theory that we can possibly have. So we really want to look at here. What do we mean? What is the difference between challenging science and denying science? So let's take a look at this. And what we're going to look at is a couple of examples. And I'm going to try to get a little bit of an idea of what we mean by denying science and challenging science. Now you can have both of these in any of these examples. I tend to look at it as the examples will decrease the level of science denial. There can be some variation in that. But what I mean is that the first example is pretty much denying science. And the later examples, there could be more of a mix of the two, that there could be some good reasons to challenge things as well. So it's not always very cut and dry that, oh, this person is challenging versus denying. So we want to take a look at a couple of examples here and see what we can find. Now let's look at our first example as the flat Earth. This is certainly one thing. Science and the consensus is that Earth is spherical. And we have a great amount of evidence that the Earth is spherical in terms of science. Everything that we've looked at, from travel off of Earth to actually looking at this Earth from space. So we have a lot of evidence there that the Earth is spherical. And it's been believed that, in fact, since the early Greeks could tell that the Earth was spherical from a number of different methods. So the flat Earth claim is that no, the Earth is flat instead. The sun is a lot closer, and that the Earth is surrounded by this impenetrable ice wall around the end, which is the Antarctic. So there's the North Pole at the center, and there's the continents that we know. Now, really, this is it to say that the Earth is flat is pretty much denying most of the scientific evidence. And you'd have to come up with some very convincing evidence that Earth is indeed flat. And again, it is not up to the scientific community to prove something that is already the consensus. Now, if someone wants to challenge that consensus, you need some very convincing evidence that it is not the case. And this has happened in the past. We have challenged various ideas that were the consensus for a very long time, and they have been overturned, whether the Earth orbits the sun or the sun orbits the Earth. Several hundreds of years ago, it was the consensus that sun orbited Earth. And now with better evidence, we do convince that the Earth, of course, does orbit the sun. But as I said, really to believe in the flat Earth really requires a denial of everything that NASA has done for decades, and not just NASA, but every other space agency, including images like this taken from the Apollo 8 spacecraft as it flew around the moon and then looked back toward Earth, seeing it very definitely as a sphere. Now, this is just one example. Let's look at a second example that we have in terms of vaccinations. Many vaccinations we've had around for hundreds of years that have done a great job of reducing diseases. However, there are those who consider the vaccinations to be dangerous. Now, this again, what is the scientific uh, evidence here? The scientific studies have shown that overall that vaccines are safe and that people are benefit by having the vaccine. Does that mean there are no side effects? Well, of course there are side effects, and people have gotten sick and died, and possibly because of vaccines. That has happened. But the overall side effects are minimal relative to the diseases that have been able to be stopped. Now, unlike less like the flat earth, there's a little bit more to think about here, because we do have relatively new vaccines. And what are the long-term effects? And that's something that we cannot study. If we want to see what's going to happen 20, 30, 50 years after someone has had a vaccine, we have to wait that amount of time and do the studies. So there are some things that we don't know for sure. But overall, there is very good evidence that vaccines are effective and safe and do help far more than they hurt. So in all, this becomes part of when we look at science versus politics, because the scientists can say what is done or what should be done or what could be done and what the probable results of that will be. But some things are not necessarily politically viable, may not work in a specific situation. So you may not be able to do something, even if it might be the best idea by science. Now let's look at our third example here. And that will be looking at climate change. So what are we looking at here? Well, what do we know from climate change? Well, there's been plenty of studies that show that the Earth's climate has warmed over the last 100 years. We also know that the climate has changed in the past. So has not just changed here. And the question is, how much of this increase that we see, especially over the last few decades, is attributable to humans? Now, there is still somewhat of a debate on that, although not as much. The consensus is that humans are responsible for this. However, there is some question as to how much they are responsible for it. So while very few scientists will say that humans are not responsible at all for this, for the increasing temperatures and that putting carbon dioxide into the atmosphere is something that we have to consider. So how much is it? Are we 20% responsible? Are we 80, 90% responsible? I would say that we're certainly not 0% and we're not 100%, but it's difficult to say exactly where we are in between there. The consensus is that we are on the very high end of that, and that most of this warming is due to human activity. However, again, what would happen? Would stopping carbon emissions stop warming? And this is where it comes back into politics again. So what are we able to do? Can we just stop all of the carbon emissions? And if we don't, will the Earth end up looking something like this, a completely barren of water? So would we be able to stop those carbon emissions? And, how much can we do in one country versus things we'd have to try to do worldwide? Because if one country is increasing its emissions, then other countries are decreasing them. What is the net effect? And it really would have to be something worldwide to be able to eliminate, to stop the warming. And even then, where are we? There are arguments as to whether we're past the point of no return or whether we can still change things. And those are all good questions that can still be studied and try to understand them better, to really look at the details of something like climate change. We know, again, are we questioning the data or are we questioning the reason? Now, there are two different things there, and they're both valid things to look at. Can we question the data? Do we say that the temperature is not increasing? That's a lot harder to do. You have to question the methodology behind how the data were gathered. Questioning the reason for the change is there's a little more leeway there. Why is the temperature changing? And that is a little bit harder to do. How do we eliminate all other variables so that we can really tell that the warming is caused by humans? Again, the consensus is that humans are responsible, so that if you're challenging that, you've got to come up with a way to say, okay, why would this not be? How can we show that the humans are not responsible for these changes? Or how can we show that the data were not gathered correctly or were not analyzed correctly? So the challenge becomes again on those who are challenging the consensus. Now let's look at our final example, which is COVID. Not that long ago, just a couple of years ago, we were hit with the pandemic. And, there were studies on how do we prevent the disease. And we see all sorts of studies then, and we see studies now as to how effective these were. So how effective were things like wearing masks and social distancing? It's very difficult to test. How effective were the masks? Well, some of the masks that were used were early on were not necessarily all that effective. Were they better than nothing? Probably. But how effective were they? How were they used properly? Did people not touch their masks? Did people dispose of a disposable mask or rewash a mask after each use? Because people who just have a mask and are constantly putting the same mask on over the course of a couple of weeks, eventually it's losing its effectiveness because you're having a lot of contamination there. How do we test something like this? How do we limit the variables? How do we put one group into wearing the masks and one group not to wearing the masks, or one group social distancing? It's a very difficult thing to test. So we don't really know for sure how effective they were. It was considered the best science at the time, that the best thing to do was to use these as ways of minimizing the transfer of COVID from one person to another. But how effective they were is still something that can be debated, because we just don't have the good studies. It is very tough to get an accurate study when you cannot, you want to, in science, you want to limit the variables. You want to have one variable that you're studying. You want to keep everything else constant. And that's just not possible when you're trying to study a whole grouping like this. And this is similar, as we talked about with vaccines. How effective are the COVID vaccines, and how what would be the long-term effects? Some of those are things we do not know. Again, the consensus was that based on the studies that we could do, that they were better to help as we went through to minimize the transfer of COVID from one person to another. Now, how could we have stopped it? Well, I guess if you completely lock down everything and confined every person in the world to their house for a certain period of time, enough time for the disease to have carried itself out and burned itself out, maybe you could have completely stopped it. So science had to go. Now, that would have been effective, but would it have been viable politically or economically? That is something that never would have gone. So never would have been effective to really be able to do that. It would have been effective against the disease, but not effective politically. So what do we have to look at are things in between that, and how good were they? It's not wrong to necessarily question those as to how effective the masks were, how effective the social distancing was. And again, it can come down to how well were people using them. Were you using them properly? Those are things that we just could not, variables we simply could not control. So again, a little more that you can question here and discuss here as compared to our original one with the flat Earth. So conclusions here, again, science should always be questioned. It is not a bad thing to question science. That is how our knowledge grows and expands. If we just accept what is currently accepted in science, we're not going to grow at all. We grow through challenges. Now, there is a difference between questioning and denying. If you're simply denying the science, then that is one thing versus questioning it. And questioning a scientific finding does not mean one is denying science, because someone questions the effectiveness of a mask, or if someone questions how much humans are responsible for climate change and wants to discuss that openly, then that does not mean you're necessarily denying the science, but you're looking. And I always look for chances to discuss things like this with people so that we can look at the debate and discuss it and look at both sides and see what is there. Now, again, some things are established. Earth is spherical. As an astronomer, I'm certainly not going to deny that. Denying this means you're denying everything that NASA and all the other spacecraft have done for decades. So that's pretty much established, and pretty much denying that the Earth is spherical would be denying science. However, others are a little more in flux. What are the long-term effects of a recent vaccine? We can't know until it's been around for a number of years. So we don't know. We can know how dangerous they are in the short term and or how helpful they are, but we don't necessarily know the long-term effects. How much of our climate change is due to man-made causes? We don't know exactly. We can estimate, and the estimate is that we are mostly responsible for it. But how will that change over the coming years as we get better and better data? And how effective were the COVID restrictions that were used? Were masks effective? Were they not? We've seen a lot of different studies some that have shown both, that they either were or were not effective. So again, there is some room for discussion here, and that looking at those and discussing openly will give us the chance to really be able to improve science overall. So politics again plays a part. While science can say something will help, can it actually be done? That is a big question sometimes, as to whether you can actually do the thing politically. Is it viable, something that can actually be done, even if it might be what science would recommend? And again, always look at the people making the claims. So who is debating this? What is their scientific background? I would certainly give more credence to a scientist, but we also have to consider that scientists have biases just like everybody else. We like to think sometimes of scientists as completely unbiased, looking at everything openly. But every scientist has their own intrinsic biases through which they make their studies. So if you're expecting a certain result, you're going to tend to see that result. And it can take a lot to overchange something that has been accepted for a while. So again, keep an open mind. Don't just blindly accept something because it is science, but do not deny something unless there's a reasonable basis in fact. And that's what you want to do, is come up with some way of legitimately challenging what is there. So that concludes this lecture on denying science. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.